Hello, everyone. Thank you for joining us today. My name is Emily Kuda. I'm Percona's Digital Marketing Manager here. We'll get started in just a moment. First, I just want to conduct a bit of housekeeping. Can you raise your hand using the hand icon located in the GoToWebinar control panel to let me know that you can hear me? Awesome. Next, during this webinar, you will be on mute. Should you have any questions, go ahead and enter them in the questions field down below. Anything that we couldn't answer will be sent to the presenter, and a follow-up blog entry will be done on Percona's database performance blog. So with that said, I'd like to thank everybody for joining us for today's webinar, Deploying MySQL in Production, presented by Percona's Senior Technical Operations Engineer, Daniel Kowalewski. With that said, I'll turn the floor over to Daniel. Thank you.
Hi, everybody. Thank you for joining me today. This is a talk that I gave in the MySQL 101 track at Percona Live in Santa Clara this year. Expanded a little bit to fit the extra time that we have here today. So this is just a very high-level overview of some best practices around deploying MySQL in production. We're going to go over some stuff around installation, configuration, both OS and MySQL, focusing on Linux because, frankly, that's all I know. We're going to talk about some basics around backups and monitoring, and a few things to remember before you put your new database into production. I'm going to jump right in on installation topics. This isn't your job, so don't make it your job. If you make it your job is going to be really boring, and you probably won't last long in it. Your job isn't to install MySQL. Your job is to run MySQL and write the configuration management stuff to install MySQL for you, and then forget about it for the next couple of years. So I'm going to try to encourage you to not do anything fancy. There are very few reasons to compile from source. Use a package manager. Do things the way the package manager wants you to do. Your life is going to be a lot easier that way. No matter what distribution you want, there are binaries in repos for you. Just do what's easy. That also helps you to stay current, so you don't have a lot of pain when you upgrade versions. You can keep up with the point releases and not have to skip 10-point releases every time you upgrade. So I mentioned your job is config management, really. It doesn't matter what you use. There are lots of config management tools out there: Ansible, Puppet, Shell, Chef, SaltStack. Try to fit in with the rest of your company, though. If your company uses config management now, don't be a silo and don't do something entirely different from everybody else. If your company doesn't use config management, I would recommend Ansible as a way to just kind of dip your toes into it. It's easy to deploy in an environment that doesn't have a lot of config management infrastructure. This helps you for a couple of reasons. One is infrastructure is code, so everything you do is tracked in revision control like it's a change to code. So every config that you change has a history behind it. You can tell what it's supposed to be as opposed to what it is, and you can tell who changed it when. And the other reason is consistency, so that all of your installations are the same and repeatable. So if you need to bring up a new MySQL server, you do it easily in the way that you've done it before. So you're going to use config management for the package installation, all of the volume and directory creation, so that you have your data directory on its own volume and permissions set and everything. Maybe for firewalls, if you're the one who manages firewalls for the boxes, you definitely want to disallow access from anybody that you don't explicitly allow. And then you're going to create some initial MySQL accounts with config management, ideally. And it's important to delete the default accounts as the MySQL secure installation script would normally do. So if you use config management, definitely do that in your config management. You don't want to build insecure MySQL servers by default. So OS configuration, and again, talking about Linux. This is a topic that we could go on for hours and hours about, but this is just a few of the basics. If you can afford SSDs, do it. And if you think you can't, think again, because it will make your life so much easier in the future if you can just do SSDs from the onset. In terms of RAID, if you're on bare metal, you definitely want some sort of RAID. The one that most people use for databases is RAID 10. RAID 5 and 6 have rate penalties. RAID 0, unless there's some sort of other level of redundancy behind it, you don't want to use for your data. You probably want to use a logical volume manager. There's a small performance penalty, but it's very small, and the flexibility of being able to resize your volumes it pays for that many times. File system, I'm not going to say a whole lot about. There are a lot of fancy new file systems. Fancy new file systems are not the place to put your critical data. Use something like XFS or ext4, and there are some mount options for you that are kind of best practice for both of those file systems. The choice between those is mainly a choice between flexibility. You can't shrink an XFS volume, or having lots of files, because XFS has a lot better inode limits. The Linux I/O scheduler, by default, it's CFQ, which is not very good for databases. It tries to do a lot more rearranging of writes than you want it to. So just switch that to no-op or deadline. They're pretty much equivalent for MySQL. They have some strengths and weaknesses you can read about, but I'm not going to go into that. For the CPU, really the only recommendation I have is to set your CPU governor to performance, and there are different ways to do this for different BIOSes and different CPUs, but you don't want your CPU taking a nap on you while MySQL's running. The number one thing that you want to configure with your system is make sure it can't run out of memory. So set swappiness to 1. That'll make sure that the system doesn't swap unnecessarily. It's only gonna swap pages out onto disk if it absolutely has to. But don't disable it, because crashing hard because some script ate up a bunch of memory is way worse than swapping. It's a good idea to use a different memory allocator like jemalloc. Particularly if you use jemalloc, you want to disable transparent huge pages so that jemalloc can reclaim memory that it's not using anymore. That's all I've got for OS configuration. MySQL configuration, we're going to do a very similar thing. We're just going to gloss over the very basics. You don't want to use the default files that come with a MySQL package. If you're starting fresh, the Percona config wizard isn't a bad start, and I've got a link to that in the references at the end of this. It's not perfect, but it'll it'll walk you through some questions and try to pick some reasonable parameters for your system configuration and your workload. It's a good place to start. The basic settings you want to pay attention to. The big one always is InnoDB buffer pool size, which is tiny by default. And this, of course, assumes that you're using InnoDB for all of your tables. Don't use MyISAM. Max connections still is by default 151. I haven't seen many installations where that is enough. MySQL can handle way more connections than that. So you're probably going to want to increase that. The InnoDB log file size, if you're doing a decent amount of writes, you're going to want to increase that. The trade-off there is the bigger your InnoDB log files, the longer crash recovery will take. But if you have big log files, then you don't have to checkpoint and flush them as often, which is good for lots of writes. The query cache, you may have seen in MySQL 8, they're deprecating the query cache. There's a very good reason for that. It doesn't scale well, and the logic around cache invalidation is not very good. So you'll almost always want to completely disable the query cache, which means setting both of these variables to 0. The InnoDB thread concurrency by default is unlimited, which means it'll let as many threads into the InnoDB kernel as want to come in, and you'll run into some concurrency issues there. We usually set this to some reasonable level, 8, 16, 32, just not unlimited, because that'll just bring everything to a halt with very high concurrency. The InnoDB buffer pool instances actually has good defaults in 5.7, but previous to that, in 5.6, I believe it was just one buffer pool instance. I could be wrong on that, but having several buffer pool instances will reduce points of contention within your buffer pool. And it'll spread your data around between different points of contention. Other things you want to consider, both of these have a trade-off between durability of data and performance. The InnoDB flush log at transaction commit controls whether InnoDB does a physical disk write to the log after every transaction. That's the only way to make sure that data is on the disk in case of a complete crash of the server. But lots of times you don't need that, and you're okay losing a transaction or two. So you can set this. Usually people set it to 2. Setting it to 0 is kind of unsafe. But you want it to flush every so often. And sync bin log is a similar thing. It will sync the binary log to disk after every write, and that makes sure that every write is recorded in the binary log so that it could be replayed later and replayed to slaves. There's another class of configuration option that you might not think of immediately, but if you don't set these initially, setting them later is a lot harder, and you're going to have a lot of pain if you don't set these initially. The character set, UTF-8 or UTF-8 MB4, which is the expanded UTF-8 that can handle emoji. You're probably going to need a store emoji in at least some table at some point, because it's it's becoming a language that we all use now. So do that now before it gets painful. InnoDB file per table is very important, and I think until 5.7 it was off by default. You definitely want that on so that each table has its own table space. That way you can shrink those table spaces when the table shrinks and reclaim that space on disk. You want to enable binary logging with the log bin option, even if you don't have any replication right now. You probably will later, and you'll probably want to do point-in-time backups, which need binary logs. You don't want to put a server in production and then realize that you need to turn on binary logging and have to restart your server. When you do that, you're gonna start getting a lot of binary logs, especially the day after you go into production with it. So you want to have a mechanism to remove those binary logs once they're no longer needed, and expire logs days is the easiest way to do that. Another kind of minor seeming one is the InnoDB NUMA interleave. This is what will spread the large memory allocations that MySQL uses, particularly the InnoDB buffer pool, between the different pools of memory on a multi-core system. And this isn't something that will bite you that hard, but it is kind of tricky to notice if it's hurting you later on. So I think it's better just to set it up front and not have to worry about it later. Another one is the InnoDB max purge lag, which sets an upper bound on the number of undo records that InnoDB can keep. If you don't set this and you have something like a transaction that lasts a couple weeks, or for some reason your hardware can't keep up with the purging of undo records, then you're going to get this history list or undo record list that is millions of records long, and those records live in the ibdata1 file. So that file will expand, and you'll end up with that file being a couple hundred gigs, and you can't shrink it, and you can't reclaim that space, and then your system's going to slow down because every new transaction has to look through all of those records, and it's very hard to recover from that situation. So I would recommend setting this max purge lag to some high value, a couple million. What that'll do is it'll slow down MySQL with its normal operations once it hits that, and it'll concentrate just on purging that history list. So that is very preferable to ending up in the huge history list situation. So backups, not going to go very far into depth with this again, but let's talk about some things that people may consider backups that are not backups. RAID is not a backup. As soon as you write something bad to a RAID, it's everywhere. You can't get back from that. Same thing with a SAN, even a mirrored SAN, because that's going to be a synchronous operation to, mess up all your data on the SAN and its mirror. MySQL replicas are a little bit better if they're delayed, but it's not going to save you from the subtle data loss that you don't notice for a week after your delayed replica has caught up, and now you've got no way to recover from that. Whatever backups you have, if you haven't tested them, then you shouldn't consider them backups, because you don't know if they're actually restorable. And the last is backups, even if they're valid and tested, if they're stored on the DB host and nowhere else, then that doesn't do you much good when that host blows up or that data center blows up. You lost your database and your backup, sorry. So this is just a little chart of the two main kind of backups, physical and logical backups, which both have their advantages and disadvantages. Physical is something like Extra Backup or MySQL Enterprise Backup. That's kind of a copy of the data files as they are on disk. And the advantages are it's very fast to back up. Usually it's low impact on a production database, and it's very simple. The downsides of that are it's hard to do partial restores if you just want to restore one table or one schema, and the size of the backups are large. If you have a lot of empty space in your data files, you're going to have a lot of empty space in your physical backup. With logical backups, that's something that almost anybody who's played with MySQL is familiar with. That's like MySQL dump or MyDumper, which is a parallel version of MySQL dump, or MySQL pump, which is a new MySQL dump's new replacement from Oracle. It's kind of still in its early stages. The big advantage of these are you can look at your data in the backup and you can pull out just what you need from it. So that one table or that one view or procedure that you need to restore from a week ago. They're also smaller, so you can store more of them, but they are slower to back up and slower to restore. Lots of times much slower to restore than to back up. So I would recommend keeping both these kinds of backups for different purposes. In addition to those, there are binary log backups that I mentioned earlier. This is what you're going to use for point-in-time recovery if you ever need to restore a database to one point in time or a binary log position, just before you deleted all your production data. The best way to do these is to stream them to another host with MySQL bin log, and then you can play them back just by piping the MySQL bin log utility to MySQL with some options for when to start, stop, and so forth. And that's why you should have enabled binary logging to begin with. Another kind of backup is incremental / differential backups. There's a little bit of a difference between the two. Both of these work by storing changes since the last backup. And incremental backups store all the changes that were made to the database since the last full backup. Differential backups will store all the changes since the last full or differential backup. So if you make a full backup on Sunday and a differential on Monday, you'll have 24 hours worth of changes in that one. Differential backup on Tuesday, that's another 24 hours of changes. On the other hand, if you do incremental backups, full backup on Sunday, and then your Tuesday backup is going to have all the changes on Monday and Tuesday. So this is only possible with stuff like Extra Backup or MySQL Enterprise Backup. Can't do this with a logical backup like MySQL dump. What you want to make sure of is that you don't go too long without a full backup for either of these, because it'll take a long time to combine these backups if you've gone a month without a full backup. As I mentioned earlier, you need to test your backups. Have a method to automate restores, and this is a way to test to make sure that in the middle of the night when you need to restore your production database, you already know how to do everything. It's as automated as it can be. It also helps you test your backups more often. You need to watch for errors. Backup tools will not necessarily fail loudly if there's an error. So you need to really watch the logs, especially with logical backups. And then while you're when you restore your backups, it's a good idea to set that up as a replica from production and use PT table checksum to actually compare the data in the tables to make sure that it's consistent. You also want to compare the schemas from production versus your restored backup, because just PT table checksum won't catch stuff like, oh, there's a view missing or a stored procedure missing. So you want to do like a MySQL dump with no data and compare that to make sure that all your objects are there. For monitoring, this is a pretty important part of our jobs. I'm not going to recommend one product for alerting. There are a bunch of them. I'm going to make the distinction between alerting and trending. Alerting is what wakes you up at night, or sends email to your inbox or whatnot. You want to alert on a few things that are really important to the application. You don't want to alert on every little thing, but you do want to alert on things that will be hard to recover from later, even if they're not immediately detrimental to the application. If you need to add a disk now, that's probably something you want to monitor, and don't monitor more than you have to, because if you get woken up 5 times a night, then you're going to ignore the really important stuff. Things that do affect the application are stuff like, I can't connect to MySQL, or MySQL went read-only, so I can't update this table. Suddenly my queries are taking a long time to execute. If you can monitor average execution time, definitely do that. Threads running is a good indicator of the general health of the database. Typically, if something goes wrong with the database, threads are going to pile up, and you'll get alerted on threads running. If your application is sensitive to replication delay, if it reads from slaves and expects current data, then you probably want to alert on replication delay. Things that will cause problems if you don't alert on them: disk space, history list size, like I mentioned earlier, auto increment keys that are running out of space in their data type, like an int key that's running out of the maximum value for an int. That will break in a very sudden and probably unpleasant way. Threads connected is something that is good to keep an eye on. We see it a lot where you'll have a lot of app servers, and somebody's going to add 3 more app servers, and each app server has 20 persistent connections, and suddenly your whole application breaks because you went over max connections and no new connections can be made. You want to check for checksum differences with PT table checksum. You don't want to have a situation where you're relying on asynchronous replication for a disaster recovery scenario, and you go to fail over to your slave and the data is different. You don't want to be surprised by that. And swap usage. If you don't want to swap, obviously. So if you swap, you probably want to know about it. Things that probably shouldn't wake you up in the night. Long transactions. This is a pretty common one. A long transaction by itself isn't a problem. A large history list as a result of that transaction is. So monitor the history list. You want to monitor, I said threads connected here, but I said it there too. Ignore it on this slide. You should probably monitor threads connected. CPU usage, if it's really hurting, it'll page you on threads running. Deadlocks are something that should be logged and dealt with by the application. It shouldn't wake up a DBA. So trending, I kind of have the opposite view on. Trend everything you can. Sometime you'll need it. All these tools are very good at trending. And it's the more metrics you have, the better it is to analyze problems. Again, this isn't stuff that's waking you up, though. It's just stuff that's being logged. You want to have a query analyzer. And this can be as simple as running PT Query Digest on your slow logs, or you can use Percona's Query Analyzer, or Vivid Cortex or New Relic have them. It's really valuable for a DBA. It lets you answer questions like, why did my memory usage grow suddenly, and the kernel killed MySQL because it was out of memory? Or where should we concentrate our tuning efforts? This is the #1 query that is slowing us down. Or 30% of these queries would be better if we added this index. And a couple more things to remember before you go live. Don't just rush into production. This is a good time to benchmark everything you can. So benchmark the hardware, the disks, the CPUs, the memory. Make sure everything is how you would expect it, because you don't want to go into production with a server and then discover that the memory is faulty or the disks are slow, and you didn't notice this before you went into production. You want to test the MySQL service itself with Sysbench or the TPCC MySQL benchmark, just to kind of have a benchmark frame of reference for what performance should be. If at all possible, you want to load test your application. So throw some realistic load that your application would create on the database and crank it up as much as you can. Figure out when your MySQL server is going to get overwhelmed. And that way, when your boss asks you in a year, how much more can we scale with this hardware, you're not going, I don't know, I guess we could double our users. And then save the results from all of these so you can go back later and look at them. Have a data retention policy. Don't say we'll figure this out later. We'll just keep adding data into this table until it causes us pain, because everything gets harder when you have terabytes of data. Figure it out now. Say we're only going to keep 6 months of data on the server. We're going to archive the rest somewhere else, or we don't need the rest. Once you get a whole lot of data, it's kind of too late to think about this. Here's a short link for some references from this. I'll post this in the chat so that everybody can click on it. And that's all I have. So it's time for questions.
Thank you so much for that, Daniel. At this time, go ahead and enter your questions down in the questions field. And as a reminder, anything that we couldn't answer will be answered in a follow-up blog entry on Percona's blog. So with that said, our first question is it, good to have your a production strategy for backup? Should it be both physical and logical?
Yes, I'd recommend both. You want the physical backups for disaster recovery, and you want the logical backups usually for selective restores, partial restores.
Okay. Our next question is what is the conversion from UTF-8 to UTF-8 MB4 look like?
I don't know that off the top of my head. I know the conversion from Latin 1 to UTF-8 or UTF-8 MB4 is pretty painful, and there are blog posts about that on the MySQL Performance blog. Um, I my gut feeling is that the conversion from UTF-8 to UTF-8 MB4 would be a lot easier than Latin 1 to UTF-8, but I'm not sure of that.
Our next question is how is PMM as compared to MySQL Enterprise Monitor?
Good question. I haven't used MySQL Enterprise Monitor for several years, but in general, PMM is a very new product. It has a lot of features, and features are constantly being added. But it may be uh, a little rough around the edges for some things, but it's definitely usable in production. Um, MySQL Enterprise Monitor has been around a long time. Um, it has some things like uh, suggesting performance or configuration changes that might be helpful. It'll actually suggest indexes to add. Um, on the other hand, PMM has a lot more metrics to look at than Enterprise Monitor does, as I remember. The other big difference is, and probably the primary difference for a lot of people, is PMM is free. MySQL Enterprise Monitor is very expensive.
Thank you. Let's see. Our next question is I'm having a system which receives data from around 300K GPS. Each unit will be inserting concurrently around 1 minute. Um, what tweaks should I add to cater for this? I'm thinking of targeting my RAM to be about 48 gigabytes with 24 CPUs.
I think that's a good question to answer later in a blog post.
All right, thank you. Let's see. Our next question is how to measure SST replication time on Percona Extra DB cluster. Is there any tool for that?
The way we normally do it is just by watching the size on disk, um, and since it's a physical backup, um, assuming that you're using extra backup as the SST method, I guess you could use MySQL dump as an SST method. But assuming it's extra backup, then the size of the joiner should be equivalent to the donor.
Thank you. Um, let's see. Our next question is how is PMM versus MEM versus Monyog?
This is the same as question I answered earlier. MEM is MySQL Enterprise Monitor. Honestly, I haven't used Monyog, so I can't speak to that one. Um, But in short, they both have their strengths, and I'm sure Manyog has its strengths too.
Thank you. Let's see. Our next question is every time I try to use Percona config wizard for my MySQL configs, it corrupts MySQL. IT doesn't, or it doesn't work out of the box. Are you, are there any suggestions on how to make this work?
I would have to see the configuration that MySQL config wizard is giving you, and whatever you're starting with. Uh, Maybe this would be a good question to post on the Percona forums with some other information, and we can take a look at it there.
Okay, thank you for that. Um, let's see. Our next question is can you put the git.io URL on the screen again?
Yeah.
Sorry about that. I'll make you the presenter again. All right.
And I will also put it. Oh, I can't put it in the chat.
If you Slack it to me, I can paste it in chat for you.
Oh, that's going to be hard too.
It's okay. Everyone will have a copy of the slides after today's webinar. Let's see. Our next question is I'm new to MySQL. Is there any best practices installation guide that you can share for the Linux OS?
I don't know off the top of my head. I imagine there are a few articles in the references here that might be useful for you. I don't know of one comprehensive guide to everything.
Okay. Let's see. I have never looked at the inodb underscore max underscore purge underscore lag slash history list size. What are some good rules of thumb for first looks at that and trying to control this on a production server?
Okay, that's a good question. It's normal for the history list size to grow and shrink a bit. And you can view this in the show engine inodb status command. There's a line that says history list length, and on Percona server, there's also a status variable that tracks it. So what I would do is try to trend it or somehow track it over time and make sure that it's not constantly growing. It should be going up and down and staying under. I think a good rule of thumb is a million. Although if you have really long transactions in your application, sometimes those transactions can drive it up to a couple million. But the main thing is you want to see it getting small in between spikes.
Our next question is, are there any OS parameters that I should be looking for?
I gave a couple of those in the slides. The vm.swappiness is a good one. There are some other kernel parameters that I didn't talk about. I think you can search on the MySQL performance blog and find some posts about those. Swappiness is really the big one, I think.
How safe is it to use a multi-source replication in production? Is it stable?
If we're talking about MySQL, the MySQL's multi-source replication, there are a lot of gotchas with that. It's tricky to set up, and uh, you really need to make sure that none of your replication sources are uh, colliding with each other. You're writing the same tables or schemas. Um, in terms of the technology, uh, MariaDB's implementation has been around a little longer, but I don't I don't know that it's more stable in terms of the underlying technology. It's just something to be very careful with when you set it up.
Thank you. Um, what should be our approach for reorganizing 4 terabytes of a MySQL database?
Reorganizing. I'm not sure what you mean by reorganizing. A common thing is the need to shrink the tables or the table spaces if they have a lot of empty data in them. You can look at some information schema um, tables to determine how much of that data file is actually data and how much is empty space. If you have a lot of empty space, I would recommend using PT Online Schema Change to rebuild that table. Basically, just uh, alter it without doing anything. So set the engine to InnoDB or add a comment or something like that, and that'll make a copy of the table and copy all the data into it. And in that way, it'll shrink the free space. Um, with that strategy, you need enough space on the disk to hold another copy of your table temporarily, um, but it'll shrink the disk space in the long run. Again, I'm not sure if that was the question that was being asked, but it's a common one.
Thank you. How do you look at the history list and how do you check its size?
In the show engine InnoDB status command, um, there's a line that says history list length, and it's also tracked in PMM as a metric.
Thank you. I heard that there's an option in Percona Extra Backup that allows us to do a binary backup and perform a partial restore. Is that correct?
Yes, it is. There's some caveats to that are in the documentation. Um, it's hard to take that table that you restore into an existing MySQL database. So what it does, it'll restore a new MySQL database instance for you that has just the tables that you asked for. It's not something that is easily just put back into your source database, but it can be done.
Let's see. At present, our current applications require us to use federated tables for allowing joins across different tables between different MySQL master slash slave pairs. I haven't found any good alternatives to this as we need to be able to write to the tables being federated as well. Do you have any suggestions?
Federated engines are never good for performance. My suggestion, just off the top of my head, would be to look into proxy SQL and see if somehow you can proxy queries to your different service or servers using proxy SQL.
All right. Um, We have a one very busy production server with concurrent writes with 25 gigabits buffer pool and 4 CPUs. Server crashing frequently with oh boy, semaphore weights exceeded. Do you have any suggestions to not happen semaphore weights? I might have been butchered that name. I apologize.
No, that's that's right. This is one of the. It sounds like one of the problems that can come with unlimited InnoDB thread concurrency. So I would look at limiting InnoDB thread concurrency um, to a more reasonable number. Um, it could also be that your disks just aren't able to keep up with the writes. So I would look at how your disks are performing.
Um, do you have any suggestions on sizing InnoDB underscore sort underscore buffer underscore size?
That's really workload dependent. Um, you want that to be big enough to cover most of your queries to avoid creating temp tables. Um, you don't want it to be too big because I believe that one's allocated immediately for each thread. Um, maybe that's one that grows as needed. I don't remember off the top of my head. But yeah, workload dependent. Try to keep it from creating too many temp tables.
In your opinion, is MySQL good for running e-commerce or financial websites as compared to Oracle or a SQL server?
Oh, that's a loaded question. I guess my answer to that is yes. Um, there are many companies that do that. Um, you're going to be really concerned about high availability and durability of your data. Um, so there are definitely some considerations to take for that, and maybe a single MySQL instance isn't a good fit for that. But yes, with an asterisk.
Um, are there any recommended ETL tools and CDC change data capture tools for MySQL?
I don't know the answer to that. Um, there's a remember there was just an internal discussion in Percona about that I could go back and uh, reference offline.
Okay. Um, so we are almost getting close to the top of the hour, so I'm gonna squeeze in a couple more questions. But go ahead and still continue to submit your questions, and we'll be recording all of this. Um, so this next question, and I'm going to combine it because I think I know what they're asking is are there any tips for deploying Galera cluster into production, or are there tips for Percona Extra DB cluster as well?
Ooh. um, I'm not sure I can come up with a good answer to that uh, right now. Yes, there are tips. No, I can't list them right now, but I can answer that one more in a blog post.
Okay, no worries. We also just did a webinar yesterday on Percona Extra DB cluster, Galera cluster, and MySQL group replication with Kenny and Ramesh. Um, So I would definitely send me a note and I can send you a copy of the recording as well. And you can check that out later. Let's see. Our next question is um, INODB underscore flush underscore log underscore at
Yeah.
transition commit. How can anyone lose at transactions? Not clear why losing a transaction is okay.
There would be plenty of use cases where losing a transaction or two wouldn't be a problem. You know, a um, a blog or a content management system where maybe you're not so concerned that uh, something didn't get submitted because the database is mainly used. 99% of the queries are session tracking, so you don't really care that some session didn't get tracked in the sessions table. Um, there are, of course, a lot of other use cases where you do care about it every transaction.
Um, let's see. Where do you insert the configuration? Is it in etc. MySQL Percona server dot config d uh, region?
There are many places where you can put the configuration. I think most people just put it in Etsy my.cnf, which is one of the first places that MySQL will look. Um, it will it will look in various places, and this depends on OS and MySQL distribution. But everything looks at Etsy my.cnf.
Okay. Um, when creating new instances with config management, do you create the config for MySQL by hand, or do you have a templated variables as percentage of the host resources?
You would probably want to have a template and use stuff like the amount of memory that a host has. Um, and there's some things like server ID that you'd want to generate a different one for every host, and there's a variable called report host that you usually want to set to the host name. So you do want to have some sort of flexible template and not just push out the same thing to every host.
All right. Let's see. Last question. When creating new instances with config management, do you? Oh, I'm sorry. I'm losing my mind here. Um, is there a tip for an efficient visitor? Logging on the master even when INOD flush TRX is set to 1.
Efficient visitor logging. I'm not sure what that question is.
That's all right. We're actually at the top of the hour. I'm going to go ahead and collect any of the other ones that were outstanding and make sure that Daniel gets a copy of these. And expect to see our answers on a follow-up blog entry on our blog today. And thank you so much, everybody, for attending. And a huge thank you to you, Daniel, for presenting today.
All right. Thank you, Emily. Thank you, everybody, for coming.